Let's look at the problem that we have on screen. It's read as figure below shows a block of mass m1 in a frictionless horizontal surface is pulled by a light string that passes over a frictionless and massless pulley. The other end of the string is connected to a block of 3 kg, block of 3 kg. I think yeah, this block is 3 kg. And then the question is find the acceleration of the blocks, both of them, and the tension in the strings in terms of M1, M2, and G. 6 marks. Okay, so let's come here. Here, let's first of all in this midterms problem, you always try to start with drawing a free body diagram. Out of space, that will be a normal, and that is going to be a weight. So no friction. They said frictionless here, frictionless surface, frictionless pulling, no friction. So there's only tension pulling this way. Tension by 2. This I call this one block 2. 1, 2. Let me go to the other diagram. This one. Its free body is like this. It's suspended. If it's suspended, no normal. Remember, normal is a force by the surface. It's a reaction of the weight. Exactly, Newton number third, action reaction, remember? And we have weight again, we have tension. This is tension by 2, this is tension by 1. Can you say it here? Tension by 2, tension by 1. Because of Newton that we can really simply state that T by 2 is equal to T by 1. The reason is Newton number third, action reaction. Okay, what is the question exactly? So they want tension. Oh, first they want accelerations of this block. Okay, from this one I can say F net is equals to ma for block 2. So what is the mass of block 2? It's m1. What is an acceleration? I don't know. What is F net? The only force acting horizontally here is tension. You wanted what? Acceleration. Okay, I could just say T m1. So I have represented acceleration in terms of m1, m2, and so on. Okay, I can come to the side again. Try to find acceleration. Acceleration will be F net is equals to ma again, but on the oh, I mixed these numbers up, but yeah, this was supposed to be 1 here, and this is supposed to be on block number 2. This is 2 now. Okay, mass of the sun, it's m2. Acceleration, we don't know, it's acceleration 2. Okay, thank you for that. They did say acceleration 2. Acceleration 2 again. So F net here, what are all forces acting here? Okay, I didn't choose my direction. My downward is positive, also my this way is positive. This is right. Okay, so what is we here in this block we have going down. What do we have going down? We have weight. What is going up? Tension. Okay, I could just say instead of writing weight, it's better because they want them in terms of m1 and m2. Let me just say m2g, mass times gravity. That is your weight. Okay, so how can I get acceleration here? It's going to be m2g minus t all over m2 is equals to acceleration 1. And we can also state that acceleration 1 and acceleration 2 are the same. While they are the same because they morph like one system, they're connected by a string. So this one can be fast, all that one is slow. So acceleration here is acceleration here, tension here is tension here. Remember, we have now two variables. We have acceleration and tension that both of the systems share. Okay. For fun, you could just equate this one and this one and try what you get. Hopefully you get something. Okay, let me try to get that something. Okay, made a mistake. Tm1 is equals to this one. Remember, we said acceleration is the same. M2 g minus t all over. Yeah, but there is no point. There is no. In a case like this, they just wanted us to represent acceleration in terms of blocks A. We did represent acceleration here. We did represent acceleration again here. You can change this t to be such a formula we have represented in terms of the other thing. Second problem will say calculate the magnitude of acceleration and the tension for mass 1 equal to this. They're now giving us mass 1, they're now giving us mass 2. So from this equation, if we substitute mass, we could do we can substitute any of this equation that the given data and be able to get your acceleration and tension. So if I put here mass, I'll know tension. That would be my equation 1. And if I put here mass 2, I'll have two unknowns again and do the simultaneous part that I wanted to do here. Yeah, you do the simultaneous part that you wanted to do here. This was supposed to be, okay, I made a mistake here. This was supposed to be over, okay. T all over m1. This is acceleration here that we say it's equal to this one. So this is this, and this is going to come here, m2. Then from here you can do your substitution. You can put your mass 1, your mass 2, and get your tension. I just cleared my board so that it won't look so disturbing. So we now have these ones of which we got from acceleration 1 and acceleration 2. We can do the substitution from here. Okay, what is going to happen now? We're substituting, right? So we're going to have t that we don't know. m1, we know m1, we were given m1 to be 5 is equal to what is m2? M2 is given to be 3. What is g? 9.8. What is tension? We don't know that. And what is m2? Do we know m2? Oh, it's 3. I just wrote it here. It's 3 again. So from here you can solve and think you're going to have your 3t. Okay, let me write legal up. Cross multiply, you're going to have 3 tension, and here we are going to have this times this, going to give you 15. 9.8, and here is going to be minus 5t. So I can take these 5t's, take them to the other side. Obviously I have what, I don't know, well, this will come up positive this side. It will be, I don't know, but hopefully it is 8t. Here we have what, 15.9, I mean 9.8, then divide by 8, divide by 8, tension, right? And now we have the answer for tension. Do your math, you find it here. 18.375 on screen. So it's tension newtons. In terms of direction, remember it's a vector, should have direction. You always look what tension you're looking at. If I was looking at tension 1, which is this one, I would have said right. If I was looking at tension 2, I call this one 2, I would have said up. So yeah, and also they wanted acceleration, right? They also wanted acceleration. Remember this equation not for acceleration. You could just say acceleration is equals to t all over m1. So what is tension force? Uh, tension is what you just got now, 18.375 all over mass 1. And then you get your mass 1. You put your mass 1. Where is mass 1? Where you mass 1? Oh, yeah, you're 5. Then you get an answer divided by 5. And then you get the answer, you put it here, which is equal to 3.675 for what? For your acceleration. Remember, acceleration should be the same in A and in 1 and 2. Let's prove that.